Today we study the calculus 1. The topic is some trigonometric integrals. How to compute the following integrations. For example, sin x n power. Integration is cosine x n power. Sin mx times cosine nx. And the product of cosine mx times cosine nx. And then the product of sin mx times sin nx. And the product of sin x n power times cosine x n power. How to compute the following integrations? You should try to understand the corresponding basic identities. Look at this. Pythagorean identities. Do you remember? Yes. A squared plus b squared equals c squared. We have known sin x squared plus cosine x squared equals 1. 1 plus tangent x squared equals secant x squared. 1 plus cotangent x squared equals cosecant x squared. Do you remember the half-angle identities? Sin x squared equals 1 minus cosine double x over 2. There are some relationships between sin x squared and cosine double x, means double angle, maybe half angle. Cosine x squared equals 1 plus cosine double x over 2. Try to remember. And then we have known the product identities. The first, the product of sin mx times cosine nx become the summation of some the same functions equals half bracket sin m plus nx plus sin m minus nx. Second, sin mx times sin nx equals minus half bracket cosine m plus nx minus cosine m minus nx. And then, yes, the product of cosine mx times cosine nx equals half times bracket cosine m plus nx plus cosine m minus nx. Try to remember. There is a relationship between the product of sin x and cosine x, and the sine and the cosine corresponding to summation. Pay attention to the multiplier, half, minus half, and half. According to the basic identities, we can finish the following examples. Now look at example 1. Try to find the integration sin x 5 power dx. Pay attention to n equals 5 is an odd number. How to do? 5 is an odd number. We can write it sin x 4 power times sin x 1 power become an even number and 1 power. Do you remember? Sin x taken in by the substitution. We can take it, write it as minus sin x 4 power d cosine x. Now, our integration variable is cosine x. We try to build up the relationship between sin x 4 power and cosine x. How to write it? Yes, we know this. Sin x squared equals 1 minus cosine x squared, copy minus bracket square d cosine x. Now we have known this. Integration function is 1 minus u square bracket square du. So at this time, the integration function write it as 1 minus double cosine x squared plus cosine x 4 power d cosine x. How to understand that? The integration function is a polynomial of cosine x. So we can write 1 minus double u squared plus u 4 power du we have the final result. Minus copy 1 become cosine x. Minus 2 become positive 2. Cosine x squared rated cosine x cubed over 3. The last term, minus copy minus cosine x 4 power rated cosine x 5 power over 5 plus c. C means any real number. So now we look at example 2. Try to find the integration sin x squared dx. Sin x squared dx. Pay attention to n is an even number. How to do? According to our known half-angle identity, we can write it sin x squared equals 1 minus cosine double x over 2 dx. How to do? Yes, half is a constant, so we can taking out half. Write it 1 minus cosine double x dx. So now 1 dx is known equals x. Cosine u dx. Try to using the substitution, so we can write it half copy 1 dx rated x minus half cosine double x rated sin double x over 2. Half times half equals 1 over 4. So we can write it minus 1 over 4 sin double x and plus c. Remember the c. C means any real number. In this example, try to remember the half-angle identity. Now look at the example 3. Try to find the sin x squared times cosine x 4 power dx. Pay attention to, in this question, both m and n are positive integer, are even number. Even numbers, how to write it? Yes, we know the half-angle identities. Pay attention to sin x squared. We can write it, this part, equals 1 minus cosine double x over 2 half-angle. Cosine x 4 power means cosine x square and then square. Cosine x square, we can write it 1 plus cosine double x over 2 together. Bracket square means the 4 power by the half-angle identities idea. So now we try to expand this expression to some polynomials of cosine double x. So now we write it this form. You can do this step by step. 1 over 8 times bracket half minus half cosine 4x plus sin double x squared times cosine double x dx. Pay attention to every term. Half is a constant. We can write it half x. The second term, half taking out cosine u du times 4 over 4. Now look at the last term, sin double x squared times cosine double x. Do you remember the substitution? Sin u squared, keep it, and the cosine u taking in become the d sin u. So we can finish it. Together we have the final result. 1 over 8, copy. Half become half x. The second term, 1 over 4 together, 1 over 8 sin 4x plus corresponding we have 1 over 2 and here sin u squared we have 1 over 3 together. 1 over 2 times 1 over 3 means 1 over 8 times sin double x cubed. It is our original functions plus c. C means any real number. Now look at this example. Try to find sin double x times cosine 3x dx. How to do? Do you remember the product of the identities? Yes, This means sin mx times cosine nx. It is the product of some two functions. So, using the product identity, the product is rated as some summation. So, we can write it half sin bracket double x plus 3x equals 5x, and then plus sin double x minus 3x equals minus x dx. So now look at this. It is our integration function. Sin 5x dx is okay. Tan 5 over 5 become sin u du by the institution. The second, the similar idea, sin minus x d becomes d minus x times minus 1 over minus 1. Together we know minus 1 over 10 cosine 5x plus half cosine x plus c. Try to remember c. C means any real number. Now look at the following summary. You try to remember the following identities. The first, sin s squared plus cosine s squared equals 1. There are some relationship between sin s squared and cosine s squared. Second, 1 plus tan s squared equals secant s squared. The third, 1 plus cotangent x squared equals cosecant x squared. Try to remember, like the form a squared plus c squared equals c squared. Now look at the second half angle identities. Half angle, so we have the first sin x squared equals 1 minus cosine double x over 2. Try to remember the formula. Pay attention to the sign. 1 minus cosine double x. The second, cosine x squared equals 1 plus cosine double x over 2. Try to remember the sign 1 plus. The third means the product of identities 1, 2, 3. On the left means the product of the different functions. Sin mx times cosine nx, sin mx times sin nx, and cosine mx times cosine nx equals the constant half minus half, half. Try to pay attention to the signs minus half. Time, the product is changed into what? Summation. Sin plus sin. Difference, cosine minus cosine. Summation, cosine plus cosine. Try to remember the product and identities. They are useful in the future study. Now look at the summary. If there is this kind of integration, sin x m power and tan cosine x n power dx. In this question, m and n are positive integers, maybe even number, maybe odd number. There are two cases. Case 1, if m and n had an odd number at this time, try to look for a substitution. If m and n are both even numbers at this time, try to use half angle identities. So now, try to using the basic idea showing the questions. Question 1, integration sin x times cosine x dx. Pay attention to, at this time, the power is 1, 1. How to write it? Yes, using the substitution. So, minus 1. By the idea substitution, we can write it copy equals copy cosine x copy sin x copy plus minus 1 minus 1 minus minus negative times negative equals positive dx. So now minus dx taking in the differentiable, we can write it for some special variable. So write it in this form. copy minus cosine x at this time minus sine x dx become d cosine x. So this form become u du. We know corresponding the function minus half u square means minus half cosine x square plus c. C means any real number. This is our method 1. Do you have some idea about this question? Yes, we have another idea. Method 2. Still by the substitution idea. How to write it? Now we can write it sin x cosine x dx. What is our substitution? Cosine x taken in become some differentiable variable. Keep sin x. And the cosine x taken in differentiable. So we can write it sin x d sin x becomes the substitution u du. So we can write it half sin x squared plus c. C is still any real number. So now look at question 2. Question 2, try to find the definite integral for sin mx times sin nx dx. Pay attention to, in this question, the corresponding upper limit and the lower limit is pi and minus pi. And m and n are positive integers. How to write it? Using the product identity. The integration function is rated as some constant. Do you remember? Maybe half, maybe minus half, times some forms. So now we should discuss in 2 cases. For example, case 1, if m doesn't equal n, at this time we have this formula. Sin mx times sin nx equals minus half. Copy the upper limit and the lower limit. Pi and minus pi. Bracket cosine m plus nx minus cosine m minus nx dx. We try to write it this equals minus half bracket cosine u dx become u. So times something over something. At this time we have this value 1 over m plus n sin bracket m plus nx. In the similar way, minus 1 over m minus n sin m minus n bracket x, giving from minus pi to pi. Try to do this. How to compute? It's very easy. Taking in pi and minus pi, sin any positive number times pi equals 0. Together we have it's known minus half 0 minus 0 together equals 0. So we know in the case 1, m doesn't equal n. At this time, integration equals 0. How about case 2? Yes, m equals n. So now we will discuss the case 2. Case 2, if m equals n, at this time, do you remember this? Sin mx times sin mx become sin mx bracket square means half angle. Formulas. So equals minus half minus pi to pi bracket cosine double mx minus 1. We know the original function, we can write it. Minus half copy cosine u making up du, so we can write it sin double mx over constant double m. Minus 1 dx, the original function rated minus x, giving from minus pi to pi. In the similar idea, sin pi for any integers always equal 0. So the first term, maybe double m pi, maybe double m minus pi. Anyway, it's 0. So now pay attention to the second term. Minus x bracket pi minus pi. Together, half pi. So become minus double pi times minus half together equals positive pi. So in the case 2, m equals n at this time, the integration value is pi. So now class is over. See you next time.